Hello, everyone. My name is Deepti Tanjore. I'm the co-lead of process integration and scale-up task within the Agile BioFoundry. In the PSU task, we conduct round-robin studies that test target host pairs among the various national labs. In this video, I will go over some such studies conducted at LBNL in the Advanced Biofuels and Bioproducts Process Development Unit, also known as the ABPDU. These studies were conducted in collaboration with PNNL and NREL. We conducted round-robin studies in FY18, FY19, and FY20. Listed here are a couple of milestones in FY20. We aimed to test at least 2 more demonstration project target host pairs. We also wanted to conduct 3 other tests that were focused on honing in on reproducibility. We expected to achieve less than 10% variability in 3 or more variables in these round-robin studies. The first study presented here was conducted in FY19 on Aspergillus pseudoterius and aconitic acid combination from John Magnuson's lab at PNNL. We tested the target host pair at the ABPDU by changing only one variable, the size of bioreactors. We used 250 ml amber bioreactors to compare with studies conducted at 20-liter scale at PNNL. We were aware that the morphology of this fungus in small bioreactors is not ideal for bioprocessing, but we took the risk as the amber reactors offer high throughput testing capabilities. At the ABPDU, we have an 250 ml amber system with substantial automation. One person can run the 12 reactors, which is a 6x productivity, 6x increase in productivity. At the ABPDU, we had commissioned the system for bacteria, yeast, and algae. However, we were expecting filamentous fungi to be a challenge. As expected, data indicated deviations. Glucose consumption in amber reactors were much lower than 20-liter reactors at PNNL. The aconitic acid concentrations were less than 0.5 grams per liter, which were much lower than the 10 grams per liter observed at PNNL. We attributed this change not only to the lower glucose utilized, but also to higher citric acid produced at the ABPDU. The citric acid results indicated variation within reactors at the ABPDU. Overall, we figured that the amber system is too small for this particular fungal host. We took pictures of the bioreactors throughout the cultivation and noticed substantial growth on walls of the impellers. Walls and impellers. We concluded that not enough of the microbial biomass was actually submerged in the culture, leading to slower glucose utilization. Also, the smaller size or higher glucose concentration in the liquid phase could have been a stress factor leading to higher citric acid production. Then we moved to another round-robin study, this time at 2-liter scale at the ABPDU. At this point, Magnuson Lab was studying Aspergillus niger for 3-HP production and were successful at half-liter scale. Given here are a couple of pictures of the reactors used at ABPDU and PNNL. Clearly, the aspect ratios of the reactors were different. It is hard to tell if morphology of the final microbial biomass was also different. So we had to rely on data, quantitative data. The fermentation process went smoothly at ABPDU. Glucose consumption among replicates was very similar, indicating no deviation within bioreactors at the ABPDU. However, the spinal spore concentration at the LBNL was much lower than that observed at PNNL. We wondered if it is also an issue with implementing PNNL's protocol around spore counting accurately at the ABPDU. As in, maybe we had enough spores, but we weren't counting them right. But from the data shown here, we saw little evidence of the impact of the spore count post 150 hours. After 200 hours, the data from ABPDU and PNNL matched very well. We considered this round robin a success across national labs and scales. If we were to conduct further studies, we would look to establish the range of spore counts over which there is no impact on bioreactor performance. We will also revisit the spore count calculation method itself to make sure we're doing it right at, just as at PNNL. So switching gears a little bit here, I will now discuss a round-robin study we conducted in FY18 with NREL. This study was focused on Pseudomonas putida, muconic acid, target host pair. In this study also, we varied reactor scale and kept all other variables same. Listed here are the details of the fermentation process. Interestingly, glucose utilization at ABPD was much higher, 25% higher. Muconic acid production was also higher at 20%, higher by 20%. When comparing yields though, the reactors at ABPDU led to 6% lower yields than those at NREL. So NREL team lead and PSU co-lead at the time, Davinia Salvachua, compared the dissolved oxygen concentrations and stirring rates of the reactors, which led to the realization that altitude difference between Golden and Emeryville, where NREL and ABPDU were located, was substantial. A dissolved oxygen concentration of 30% in Golden corresponds to 35% in Emeryville. Bioreactors have dissolved oxygen probes that are calibrated against 100% saturation at the particular location. So even when we were administering 30% dissolved oxygen per NREL's protocol, we were actually administering a much higher oxygen level in the bioreactors. Davinia also did a thorough comparison to look to other factors where we may have missed the mark. We are now conducting a study that ensures that all these other factors, including bioreactor sizes, are similar between the two locations. If we still see a 25% difference in glucose consumption, we will be able to further look into our hypothesis of altitude difference. We will then conduct testing at different dissolved oxygen levels to confirm the hypothesis. This may be our last round-robin study before we start looking into reproducibility within bioreactors at each of the locations. Thank you very much for watching this video, and please do share any concerns or comments with us. Looking forward to your feedback.